Okay, and we're going to look and see which earthing arrangement we have this time. Could be the same as our last video. Our last video we identified a TNCS earthing arrangement. We're going to have a look and see what we've got this time. So as before, we've got a kilowatt hour meter. We've got our cutout section here, including our cutout fuse, which this time is rated at 60 amps. Remember, it can either be rated at 60, 80 or 100 amps for a single phase domestic dwelling. We've got our tails. Our tails to our consumer unit here, as before, are sized at 25 millimeters squared, and our earthing conductor is sized at 16 millimeters squared. Please note in this installation, the supply authority's side of the meter, the tails are 16 millimeters squared and not 25 millimeters squared. This installation, unlike the previous one we looked at for the TNCS earthing arrangement, has no double pole switch inserted in the tails. So in these tails here, we cannot isolate the consumer's unit itself. Isolation for the distribution board has to occur within the distribution board itself. So in the event of you requiring to change the distribution board, you would need to pull out, in this case, the 60 amp fuse, which is sealed by the supply authorities, and you would require permission before breaking those seals. So to work out the earthing arrangement we have this time, we'll look at the supply authority's cable incoming into the bottom of the cutout, which is here. We can see it's considerably larger in size, physical size that is, than the one we had on our previous earthing arrangement. And we can quickly identify here this braided section of the sheath of the incoming supply cable then terminates into our MET, our main earthing terminal, and goes off in the 16mm earthing conductor to our consumer's unit. So we've got a slightly different arrangement here. We haven't got it coming out of our cutout as we did on our TNCS earthing arrangement, where the earthing conductor and neutral were together within the cutout. We've actually got it separated off the sheath of the incoming supply cable. We see the connection from the sheath of the incoming supply cable has been labelled with safety electrical connection, do not remove. If this was to be disconnected from the installation, the whole installation would lose its incoming earth. So we got to look at the supply authority's cable incoming to work out the earthing arrangement we've got. We can see this time we have this steel outer sheath being taken from the outside of the supply authority's cable into the MET, the main earthing terminal, and not in our previous earthing arrangement TNCS, coming out the same termination point as the neutral. So therefore this earthing arrangement must be different than the one we previously looked at in our video. So we're now looking at a earthing arrangement where it comes off the outer sheath of the supply authority's cable. So we're looking at a TN, a terra neutral, and then S for separate. In other words, the supply authorities will bring in a line conductor, a neutral conductor, and a separate earthing conductor into the installation. The two common materials used for this separate earthing conductor coming into this installation are either lead of the sheath of the cable or steel of the sheath of the cable. In this instance, we're coming off with a connection to a steel sheath cable. If it was a lead sheath cable, care must be taken to check the clamp around the lead is correct. Sometimes they try and use bonding clamps, which works really like holding putty or Play-Doh. The more you squeeze it, the more the lead will move away and be less tight. You normally have to sweat onto a lead sheath cable in order to connect your earthing conductor. So to recap then, the supply authorities have brought in a cable containing 3 conductors. Line and neutral conductors terminated within our cutout, separated for a neutral, and the line going through, in this case, the 60 amp incoming fuse. We're using the outside sheath of the cable to provide us with our earth connection. Okay, so it goes into our MET and then goes out into our 16mm earthing conductor. The incoming supply authorities cable often have lead or steel sheath for that protective conductor. In this case, we're connected to one which is made of steel. We will see later on in our learning at college that the TNS, the terra neutral, the earth and neutral, are separate. TNS earthing arrangement has a maximum external earth fault loop impedance of 0.8.
So when we turn up an installation, possibly the first thing we're going to do is look at the mains end to determine the earthing arrangement, the size of the incoming fuse, and the size of the tails and earthing conductor, whether they're a TNS earthing arrangement or a TNCS earthing arrangement. So as we look at the incoming cable from the supply authority into the bottom of the cutout arrangement here, we can see there is a connection or a clamp around the outside of this cable, which then takes a conductive material into the MET. This earthing arrangement is TNS. To remind you that T for terra, the French word for earth, N for neutral, and S for separate. So in this case, the earth and neutral are separate from the supply authority's cable. So it's brought you in a separate protective conductor and a separate neutral conductor into the installation, making the earthing arrangement TNS. The cutout fuse in this installation is 60 amps, but could have been 80 amps or 100 amps. The double insulated meter tails are 25 millimeters squared, and the earthing conductor from the MET into the distribution board is size 16 millimeters squared. All this information needs to be inputted into our test paperwork, along with either the measured reading for external earth fault loop impedance or the maximum external earth fault loop impedance for a TNS earthing arrangement is 0.8 ohms. The left-hand side of this drawing shows the supply authority's cable with a separate line conductor, a separate neutral conductor, and a separate protective earth conductor coming into our installation. This is the cable we can physically see in the bottom of the cutout. This cable often comes to installations underground, but can also come overhead. This drawing also only shows one of the 3 star connected windings on the supply authority's side, as well as the centre tap point to earth. The supply authorities will provide the metering equipment and the cutout fuse sized 100, 80 or 60 amps for a single phase installation. The supply authority's protective earth will be either lead or steel. The installation showed on the right hand side could be a lot shorter in length than the supply authority's cable, comprising of a line, a neutral and a CPC conductor within circuit. As with the supply authority side, we have a separate line, neutral and CPC in circuit. The fuse for this circuit will not be 100 amps, but considerably less, maybe 20 amps, and would be located within the distribution board itself. The maximum external earth fault loop impedance for a TNS earthing arrangement is 0.8 ohms. The earth fault loop impedance path of an installation connected to a TNS earthing arrangement. In the event of there being a fault between the line conductor in the installation and an exposed conductive part, the fault path or earth fault path would be as followed. The exposed conductive part would become live. This is connected to the circuit protective conductor, the CPC. This would become live. This goes back to the earth terminal situated within the consumer's unit, which would become live. This is connected to the incoming earthing conductor, which comes in with the double insulated meter tails. This earthing conductor becomes live. The earthing conductor is connected to the lead or steel sheath of the supply authority's cable, which becomes live. This is connected to the earth neutral point within the transformer, which becomes live, back round the line conductor, completing the circuit. The fault current will pass through the main cutout fuse rated at either 100, 80 or 60 amps, but will not cause operation. The fuse that will operate is the one closest to the fault. In this case, the fuse located within the consumer's unit will operate, clearing the fault in circuit. This is the full earth fault loop path and needs to be a very low impedance in order to generate a very high fault current to cause rapid operation of the overcurrent protection device. We looked at 2 maximum times for disconnection, either a maximum time of 5 seconds or a maximum time of 0.4. I have described to you the earth fault loop path for an installation connected to a TNS earthing arrangement. Total earth fault loop impedance, ZS, is measured at the furthest point of a radial circuit and comprises of the impedance offered by the line conductor, R1, the impedance offered by the circuit protective conductor, R2, and the impedance offered by the supply authority's cable. The maximum impedance of the supply authority's cable depends on the earthing arrangement. The drawing shown here is a TNS earthing arrangement. The supply authority's maximum impedance of that cable, ZE, is 0.8 of an ohm. The total earth fault loop impedance of a circuit measured in ohms is found by ZS, being the total earth fault loop impedance, equals ZE, the supply authority's cable's impedance, added to R1, the line conductor's impedance, added to R2, the circuit protective conductor's impedance. The formula is ZS equals ZE plus R1 plus R2.